Hi everyone. So today's lesson is on something called integration by U-Substitution. So just to kind of give you big picture here, what we're talking about is really the tail end of Unit 6. So yes, we just took a Unit 6 test. Unit 6 is a really large unit, and I just feel like it's too much to test on it all at once. So these last few lessons in Unit 6, we're going to just kind of clump together and do a quiz on them. And all of this focuses on other ways to find integrals. Okay? And so the issue is, when we found derivatives, we had a big list of derivative rules that someone somewhere proved to us. And we could take a derivative now of anything. Like we have chain rule, we have product rule, we have quotient rule. So no matter how ugly you make your function, we could find a way to take a derivative if we absolutely had to. Integrals do not work the same way, because integrals are all about recognizing the derivatives of other functions, right? So if you look at a function and you don't recognize it as a derivative of something else, then finding that antiderivative is very difficult or impossible. So these next few lessons are really talking about what are some other methods, some very algebra-y methods that we can use to find that antiderivative, okay? And one of the methods we're going to use, this is like to undo the chain rule, and you'll see what I mean by that as we do a few examples. This is called U-Substitution, and that name will make sense to you, I think, in a second. So for this first example, this integral of sine of 3x, and remember this symbol is really just saying find an antiderivative. You already know how to do that. We've done problems like this. I hope that you would look at that and go, oh, I see a 3x, so I need a 1/3, right? And then I'm going to do the antiderivative of sine, which is negative cosine, and you would get your answer, okay? I'm going to do this one now with this process called U-Substitution, and you might look at it and go, well, that's way harder. Why wouldn't I just do the 1/3 thing? And I love it if you do understand why you're putting a 1/3 in there. This is going to serve two purposes. First of all, it's going to justify why we need the 1/3 in there for those of you who are skeptics, okay? And secondly, there are some functions that you can't do without doing U-Substitution. Like if I look down at the bottom of this page, I'm seeing some that there's no way you could do an antiderivative sort of by hand without using U-Substitution. So that's why we have to learn it, but I'm going to start with one that's kind of familiar territory to you. Let me see if I can figure out how to make my face go away. There we go. Okay. So U-Substitution we're going to use anytime you have a function trapped inside another function, because that is where chain rule is coming from, right? And so here I look at this thing and I see a 3x sort of trapped inside this sine function. So what I'm going to do is I'm going to go off to the side, or usually I go down underneath, and I'm going to say that I'm now going to call that 3x u. Don't ask me why someone chose u, but we're going to use u. Okay, now what I'm going to do is I'm going to take the derivative of that 3x, okay? And I'm going to write this out kind of the long way the first time. You're going to be able to take some shortcuts in future problems. And if you don't know why I'm taking a derivative right now, that is totally okay. It'll make sense to you hopefully in a minute. When I take a derivative of u, I can call it du dx. And then my derivative of 3x is just 3. Okay, so far what I did is I took a derivative of that little thing that I defined as u. Okay, my mission here, well, I guess I should have started with this, but I defined this thing as u, and so now I could go back up here to my integral, and I could say, now what I'm finding is an integral of the sine of u. And I like that because I know how to find an antiderivative of sine of something, right? I don't have to worry about 3x anymore. I swapped it out with this u. The problem I'm going to run into is the fact that I have a dx sitting here, which means I'm supposed to be taking an integral in terms of x, and now I have a u here, okay? So that's the problem that I'm looking to solve down here with this derivative piece. So watch this. What I'm going to do is I'm going to take this dx and move it to the other side. So now what I have is du equals 3 dx. Okay, so I think about it as multiplying by dx on each side. And this is what I meant when I said you can take a shortcut. You're going to do that every single time. So in future problems, what you're going to see me do is just as soon as I take this derivative, I'm just going to call this a du, and I'm going to put a dx over here on this side. But now what I want is I want this dx by itself, okay? Because I want to be able to substitute in place of this dx up here. So let's move the 1/3 to the other side. Okay, I'm sorry. Let's move the 3 to the other side. And when I do that, it's going to become a 1/3. So now I'm going to say 1/3 du equals dx. This would be an excellent time to pause the video and just make sure that you understand everything that you've written down so far. Make sure you understand all the steps that I just took here in red. Okay, so now, like I said, this dx is a thorn in my side. But now I have an expression down here for dx. dx is really equal to this thing, 1/3 du. So I'm going to put that right there. And so now my integral reads like this. Now I'm doing an integral of sine of u times 1/3 du. And I like this way better because now it's telling me, hey, I'm taking an integral in terms of u instead of in terms of x. And I can do that. I know how to take integrals, right? Okay, so my antiderivative of sine, right? I'm thinking about the reverse derivative. That would be negative cosine. And if you're not sure about that, think about like the derivative of cosine is negative sine. So if I have a positive sign, then my original function must have been negative. So now I can say pretty confidently that this derivative, or I'm sorry, this antiderivative is negative cosine of u. But I do still have a 1/3 here, right? So this is going to be times 1/3. Okay. By the way, that's where your 1/3 comes from. Remember, every time we had a 3x, I said, oh, just throw a 1/3 in front and it'll be fine. This is kind of the mathematical reasoning why I need that 1/3. And then I have one last tiny thing to do, because my original problem was not in terms of u, it was in terms of x. So see this right here, what my u equals? I'm going to swap that back in. And I'm going to now say that my final answer is, I'm going to put the 1/3 in front here, so I'm going to say negative 1/3 cosine of 3x. And then we're going to just say plus c. That is the U-substitution process. So again, now would be a fantastic time for you to pause this video and just kind of talk this through with somebody around you or even to yourself. Just make sure you remember what all of those steps were and what I did next and all of that. Okay, before I dive into the next one. Okay. Remember, when you're searching for your u, you are picking out something that is trapped inside of something else. So like when I see this function, I see 4x minus 1 trapped inside here. Okay, so that's going to be my u. U is 4x minus 1. And then I'm going to take a derivative of u. So I'm going to now say this is du. Derivative of 4x minus 1 is just 4. And then because I took a derivative, I'm going to put dx on there. Okay, so that's what I was talking about up here when I said you can kind of just jump straight to this step. But I did a derivative here, du on this side, dx on this side. But my mission is still to get dx by itself so that I can trade it out. So I'm going to move this 4 to the other side and make it a 1/4 du equals dx. And now I am ready to substitute. So now I'm going to go back up here to my integral. And I'm going to say this is really the same thing as doing a square root of, and my 4x minus 1 is now u. Okay, and my dx is now a 1/4 du. And sometimes you'll see when I have just constants like this, one of the things we learned about integrals is you're allowed to pull them out front. So you might also see this written this way, 1/4, I don't care how you write yours, but 1/4 times this integral of square root of u du. But that just kind of focuses us in on like, what am I actually trying to find an antiderivative of? Okay, so let's use our antiderivative skills here. This u, the square root of u, I'm really going to think about this as a u to the 1/2. So now I'm doing my antiderivative. I'm going to add 1 to my exponent, which makes this u to the 3/2. I'm going to multiply by the reciprocal, or think of it as dividing by 3 over 2. So this is going to be 2/3. That was just the antiderivative process, right? Add 1, divide. But I do still have this 1/4 hanging out here, so that's going to go hang out in front here. Okay? And I also need to swap my u back in. So I'm going to kind of do all of this at once. I'm going to clean this all up at one time. I'm going to put my fractions together. So that would give me a 2 over 12, which is the same as 1/6. And then for the u, I'm going to put 4x minus 1 back in. And then that would be to the power of 3 over 2. And then it will have a plus c. Okay, I went faster that time. If you need to rewind and watch it again, feel free. If you need to pause and talk through those steps again, highly encourage you to do that. I'm going to jump ahead just a little bit because here's the thing. These first 4 examples really are all just going to be like this, where this derivative is just 4, and so that means I'm going to have a 1/4 in my answer. Okay, but otherwise everything else is going to stay exactly the same. Now the 1/4 gets a little hidden here because it gets mixed with the 2/3. But all I did was put in a 1/4. So like this one, all I'm going to need is a 1/7. This one, all I'm going to need is a negative 1/2. Ooh, and you do have to recognize that as a secant squared. But I'm not going to worry about those too much, because what I really want you to see are the ones that you couldn't just do off the top of your head without U-substitution. I want you to really need it. Okay? So I'm going to jump all the way down to this bottom example on this page. Okay? So I see sine to the 4th of x times cosine x, go lower here, dx. And I'm trying to take an antiderivative. And this is what I'm talking about, is that this function is really hard to recognize as the derivative of something else. It is a derivative of something, we just don't know what. Okay? I do want to remind you that this sine to the 4th of x is really like sine x to the 4th power. And remember, when we're choosing our u, we're looking for something that's trapped inside something else. So lots of people are drawn to this cosine x, and I know why. Okay? But what we want to do is look at this thing that's trapped inside this power of 4 function. Okay? So that's going to be my u. My u is going to be sine x. And now I'm going to take the derivative. This gets really tricky because we are leaping back and forth between derivatives and antiderivatives. Okay? So you've got to keep it straight in your head, especially with these trig functions. The derivative of sine is cosine. Okay? The antiderivative of sine is negative cosine. But the derivative of sine is cosine, and that's going to have a dx because I took a derivative. And I'm going to move it to the other side just like I moved all the other ones. I'm basically just going to do 1 divided by. So I'm going to move this cosine x over and say this is 1 over cosine x times du equals dx. Okay, so same thing. I just divided by cosine x, got dx by itself. Okay, let's write out what this integral looks like now. So I'm replacing this sine x with a u. So my integral now says integral of u to the 4th. Okay, that takes care of this. I do still have a cosine x here. But in place of dx, I'm putting all of this. So 1 over cosine x times du. And I want you to see what magical thing is going to happen now. Okay? That cosine x that was bothering us, because we'd be really stuck right here. This has an x in it, right? And I can't do an integral in terms of u while I still have x's hanging around. But the fact that I'm multiplying by 1 over cosine x is going to let these cancel. And that's what a good u substitution should do, is it should take care of these extra pieces that we don't really like. Okay? And so now I'm just doing an integral of u to the 4th power. Okay? Well, we know how to do that. Let's just do an antiderivative here. I'm going to add 1, so this is going to become a u to the 5th. And then I'm going to divide, so that's a 1/5. I do want to point out that I want to pay attention over here because sometimes there's numbers that float around here. In this one, it's just a 1, so I mean I could put a 1 if I really wanted to. But just be careful because sometimes there's other numbers floating in there that you have to incorporate. Okay, that's my antiderivative. And now let's swap my u back out for sine x. And so what I really have now is 1/5 times sine of x to the 5th power, and then plus c. Okay, and so here's the reason your eye was drawn to that cosine. Here's where that random cosine came from. Pretend none of this existed. Pretend I started you with this and I said, hey, take a derivative. Okay? Hopefully what you would do is go, hey, wait a second, I need the chain rule. And you would say, let's start with a derivative of sine, which is cosine. Okay? And then you would say, now let's multiply that by the power of 5 derivative. And so I would go 5 times 1/5. Well, that cancels out. That's why I don't have any number here. And then this exponent would come down 1, and so it becomes sine to the 4th. Okay? But you're multiplying by cosine because you had to do a chain rule inside here. So that's what I mean when I say that we're undoing or unraveling the chain rule here. Okay, let's do one more just for funsies, because we have not seen one where we actually have to plug in any endpoints yet. And there is one of those back here. I don't actually think there's any of those on your homework tonight, but notice this is a definite integral, which means I'm going to be using fundamental theorem and plugging some numbers in once I find my antiderivative. But really what I want you focused on is the process up to that point. The plugging in the numbers, like, we can do that later. Okay? So let's do our U-substitution. Look for the thing that's trapped. And so in this case, this whole thing is trapped inside a squared function. So that's going to be my u. X squared plus 2x minus 3. Let's take a derivative. So I get 2x plus 2. And I'm going to throw a dx on there because I took a derivative. The minus 3 went away because it's a constant. I'm taking a derivative. Now I'm going to take all of this. I really should have written this in parentheses because all of that is being multiplied by dx. Move it to the other side. So I'm going to have 1 over 2x plus 2 times du is equal to dx. And now let's rewrite my integral. So my integral up here is now this thing underlined in red, that's going to become my u, and that's being squared, times x plus 1, times, in place of dx, I'm putting this thing, so 1 over 2x plus 2 du. Okay. So a second ago, I said a good u substitution will cancel out any x's that you have. And I don't quite see how this is going to cancel. This would be a great time for you to pause the video and see if you can think about how you can get this x plus 1 to cancel. But I'm going to assume that if you're still watching that you have paused and thought about it and you don't know how. Or maybe you do and you just want to see if you're right. Regardless, take a look at this thing down here, this 2x plus 2. Let's pull a 2 out of that. Let's do some factoring. Okay, 2x plus 1 is what I'm going to call that. Okay, so I pulled a 2 out, and then, hey, would you look at that? I have an x plus 1 that's going to cancel with an x plus 1. So now I'm doing, actually I'm going to take one more step and rewrite my integral one more time. Now what I have is an integral of u squared. Over here, I have a 1 over 2 left. This is what I meant when I said sometimes you get like random floating numbers. So I have a 1/2. And then du. And now let's do my antiderivative. I'm going to bring my antiderivative down here. So that's going to be u cubed. Let's do this. U cubed with a 1/3 in front. That's me doing an antiderivative. And I'm going to grab this 1/2 and put it in front here. So that's really going to become a 1/6. And then back in place of the u, I'm putting x squared plus 2x minus 3, and then that is to the power of 3. Okay, we have to deal with those endpoints, with the 1 and the 2. I'm going to do that here in just a second. but make sure that you can follow what I just did here. And again, if you need to rewind, this would be a good time to do it. Okay. My endpoints from 1 to 2, right? 1, 2. This is where I'm going to plug the 2 in, and I'm going to plug the 1 in, and then subtract. All right, this is fundamental theorem of calculus. We need another color. Okay. For the sake of making my life easier, I'm going to hold off on this 1/6. I'm going to wait till everything else is done and then deal with the 1/6. So I'm going to kind of just say 1/6 and then open a big set of parentheses and then a smaller set for plugging in my 2. So now I have 2 squared plus 2 times 2 minus 3. And then that's being raised to the 3rd power. Minus, now let's plug in my 1. 1 squared plus 2 times 1 minus 3. And that's being raised to the 3rd power. And again, I'll deal with the 1/6 at the end. I usually find those fractions are easier to deal with later. This is 4 plus 4 is 8. 8 minus 3 is 5. So I get 5 cubed minus 1 plus 2 is 3. And then 3 minus 3 is 0. Okay, so I get 0 cubed. And that's still being multiplied by 1/6. And so then I get 125 for 5 cubed. So my final answer is 125 over 6. That's my integral. Okay? That would be the area under this function. Okay, it's all the fun you can have in one problem. Okay, for today, you do have new homework packets that I've left out on the front table for you. The first assignment is on U-Substitution, and I'd like you to just try the very front page. Okay, so you do not have to do the back of the page. The front page doesn't have anything where you're plugging numbers in like this one. It's just finding the antiderivatives. Give that a try. If you're feeling shaky about it, I've already got tomorrow built in as a day to spend practicing with this because this is tricky. Okay, so give it a try tonight. We'll talk about it some more tomorrow.